Dear students, we have been discussing about sociology of science in the last few lectures. In the last few lectures, I talked about sociology of science as a subject which was developed by Robert Merton, renowned sociologist from United States of America. Now we are continuing that same discussion. We will look at some of the other contribution of Robert Merton in sociology of science. I started with, for instance, sociology of science of Robert Merton in the context of ethos of science. What the ethos of science that he has developed, which are the guiding principle for the scientific community. Then we spoke about the counter norms, the norms of science, the norms which guide, regulate the scientific community, as well as the counter norms which were developed by I. Mitroff based on his study of Apollo moon scientists at NASA in 1974. So that is just to put things in a perspective regarding the norms and counter norms in science, which are the guiding principles for the scientific community. Now we will look at another issue within sociology of science, and that is Robert Merton's discussion on the relationship between, the linkage between the social needs and scientific and technological advancement. In other words, how the social needs of a distinct time period can lead to scientific and technological innovations, scientific and technological developments. To discuss that, I will look at one of the chapters of Robert Merton in his book Social Theory and Social Structure, where he is talking about the relationship between science, technology and society in 17th century England. So the title of the chapter is Science and Technology of 17th century England. Now the question is, why 17th century England? Why he chose 17th century England? We know very well that 17th century England was the nursery of industrial revolution. The industrial revolution took off in England in 16th and 17th century. That was the high time where scientific and technological innovations were taking place or coming into being. That was a time of industrial revolution. That was a time of scientific, technological inventions. That was a time of new things. That was a time of entrepreneurship. That was a time of mercantile development. That was a time of voyages being taken. That was a time of England slowly emerging as the most politically and militarily powerful country all over the world through its voyages, through its conquering of various countries all over the world in various continents. And that was possible. England could become a military might not only in Europe but all over the world. England could become a politically stronger force. It could conquer most parts of the world because of its scientific and technological advancement. And that was possible because of the need of English people to develop, to innovate, to bring about changes in their lifestyle. Now, Robert Merton paid attention to the social needs of 17th century England, how it drove, how it shaped the scientific and technological advancement. Now, in order to explain that, first point that he makes is that sociologists of science are concerned with types of influences involved, either facilitative or obstructive. Extent to which these forces, this type of influences prove effective in different social structure and the processes through which it operates or they operate. The point is, What are those social forces that act as a facilitator or act as an obstruction to scientific and technological advancement? In order to understand that, he formulates his thesis in the following way. The first formulation of the problem is the identification of personal motivation of scientists with the structural determinants of their research. That is, whether it is a personal motivation of the scientist, personal interest that drove the scientist to look for newer things, to innovate, to bring about changes in their immediate social world. Or the second formulation, the belief that socio-economic factors serve to account exclusively for the entire complex of scientific activity. That is, in other words, it means the socio-economic factors play a very important role in the formulation, development, advancement of scientific activities. And the third one is imputation of social needs where these needs are absent. That is, you impute social needs to people, actually to the society, but these needs are absent. In other words, it means that we make an argument, we claim that there are certain social needs which lead to scientific activity, but that may not be so, right? The scientific activity may have happened because of serendipity, because may have happened because of personal interest, may have happened because of changes in time, right? So, which of this argument should hold? We will look at it at the end of this discussion. He says that these three ways we can formulate the problem regarding the relationship between social needs and scientific activity. The first, it is a personal motivation of scientists which has a bearing on development of scientific research, the advancement in science and technology. Second is the social needs which led scientists to look for practical solutions, to look for utilitarian solutions to practical problems. Or the social needs are actually on ground reality, they are absent, but we have a tendency to claim that these are social needs which are connected to the development of science and technology. Now, if we look at the personal motives, what can be personal motives? Personal motives can be personal aggrandizement or wholly disinterested desire to know. That is, you are curious, you have a passion, you have to know the world, you want to explore the world, you have no personal stake. It can be personal motive. The development of 17th century science was determined essentially by the social structure of time. Now, for example, if you look at, we know that Newton made some astronomical observations, but his reliance on the astronomical observations was made possible because Greenwich Observatory built for the benefit of Royal Navy. Royal Navy, the British Navy. For the benefit of the British Navy, the Greenwich Observatory was made, and thanks to the Greenwich Observatory, Newton could make all these astronomical calculations. He had his personal interest to have more knowledge of the natural world, about the solar system, but he took help from the Greenwich Observatory, which was essentially built to provide support to the British Navy. So, it is a personal motive, but this personal motive was actually structured by indirectly by the social needs. So, in that context, Robert Merton says the relationship between science and social needs are twofold. One is direct, one is indirect. The indirect is some research is deliberately done for utilitarian purposes, practical purposes. You take up a research in order to solve a practical problem. For instance, we want better, bigger ships to be built, we need to make some research in the field of hydrodynamics, right? That is a direct thing. We want to stop the depletion of forest reserve, we make some botanical research. That is a direct need. We want to understand grasp the problem of latitude and longitude at sea, so that the voyages can be safe. So we make some scientific research. That is a direct need. In order to help those mariners at sea, we are studying the longitude and latitude. That's a direct need, direct social need, and there is a direct relation between the social need as well as the scientific research. Indirect, certain problems and materials for scientific research stems from practical exigencies, that is a state requiring urgent action, though scientists may not be aware of it. That is, the scientist is working on something and comes up with something, but he or she may not be aware that he or she is making use of materials and resources which has been built or developed to cater to certain social needs. I gave you example of Newton. Newton was making his astronomical observations, was making a study of astronomy, but unknowingly he was making use of Greenwich Observatory, which was built for the help of the Royal Navy. So that is an indirect need. But 17th century science and technology were not devoid of each other, as Sombart argued. Robert Merton says, and he quotes Sombart, who says that 17th century science and technology were devoid of each other. That is, there is no relations between basic pure science and application of the science in terms of solving the practical problems. He says that is not the case, as Sombart was arguing that 17th century England, in 17th century England, the science and technology were divorced from each other. They were not connected. The pure science and practice and application of that science to solve practical problems, social problems, it was not there. But that is not true. What Sombart says is not true. That is what Robert Merton argues. Many scientists turn their theoretical knowledge to practical problems. For instance, Newton, Boyle, Hooke, Halley, Higgins, Wren, all the scientists, they turned their theoretical knowledge to solve practical problems. I'll just write down some of the names of the scientists. Newton, so these are some of the 17th century English scientists who turned their attention to solve practical problems. They had basic knowledge of the pure sciences, they had theoretical knowledge in their field, but they did not stay there. They did not confine their theoretical knowledge to universities, to research institutes. Rather, they wanted to apply those theoretical knowledge to solve practical problems. One of the practical problems of that time was military demands. Military demands prompted increased speed in shipbuilding and improvements in naval architecture. So, why did they want to have faster ships, and why did they want advancement in naval architecture? Because sea transport was the most common mode of transport in 17th century world, and the British wanted to have better ships, faster ships, bigger ships, so that they can take voyages, they can go to other countries, make trading links, establish businesses there, and if possible have political control over those countries, and so that they can use the raw materials of those countries and which can be manufactured back in England. So they wanted to have, they had political interests, they had economic interests, and hence they wanted improvement in naval architecture. And for the improvement in naval architecture, they turned to the scientists to bring about those improvements, advancements. So the scientists, in order to solve these practical problems of building better ships, larger ships, ships which could be built in quick time, in double quick time, that was their attention. They wanted to build warships. Now, statistics suggest that expansion in both mercantile and military marine happened since late 16th century. So, businesses as well as the British Navy developed its shipbuilding, developed its ships from 16th century onwards for business purposes as well as for military purposes. And the increase of commercial voyages to distant points such as India, North America, Africa, it stressed the need for accurate and expedient means of determining position at sea, of finding longitude and latitude. The scientists were concerned with possible solutions to this problem. How do we solve the problem of longitude and latitude at sea? Because if we can solve that problem, we can reach distant points on Earth. We can develop, through that we can develop our business perspective. We can expand our political control. So the mathematics and astronomy, they were advanced manifold through research in this direction, in the direction of studying of longitude and latitude, trying to find out the position at sea. For example, Napier's invention of logarithm was expanded by Henry Briggs, and Henry Gallibrand was of help to astronomers and mariners. This is a Napier's invention of logarithm is a theoretical contribution, but that was used by the astronomers and mariners for practical purposes, to understand the problem of to understand and grasp the problem of longitude and latitude, to understand the position at sea. They made use of Napier's invention of logarithm. Spratt, a historiographer of that era, he said advancement of navigation was one of the chief aims of Royal Society, that is Royal Society of England. What was their intention? Advancement of navigation. Why? So that they can be a powerful economic and political force in the world through their advancement in naval architecture and navigation system. And findings of longitude was one problem that engrossed the scientists and fostered profound developments in astronomy, mathematics, geography, mechanics, and it led to finally the invention of clock and watch. So, in order to find a solution to the problem of longitude, the astronomers, the mathematicians, the geographers, the mechanical engineers all turned their attention to it, and it finally also led to the invention of clock and watch. Now, one of the important reasons why science and technology developed multifold in 17th century England is because of the social status attached to the scientists. The scientists who could invent, who could come up with new technology, new gadgets, they also got more social acclaim, got more social prestige. The social mobility became more fluid for them. They could go from lower class or lower middle class to upper class in no time because of their reputation as a scientist. And that also acted as a strong social forces, strong driving force for the scientist to look for new inventions, to work on new gadgets, new machines, which could ensure social acclaim, social prestige to these scientists. So that is one of the social needs which led to advancement in science and technology, that the promise of social mobility, more social prestige, more social acclaim, more economic benefits, that definitely triggered interest in the scientist, and that led to scientific and technological advancement in 17th century England. And there were also this issue of developing and advancing the naval architecture, because they wanted to be a dominant naval force in the world so that they can be a stronger political force, they can develop their business, the business perspectives could improve. Hence they wanted to build better ships, bigger ships, stronger ships, ships which can carry artillery, the warships, and the ships has to be built in double quick time. So they turned their attention to that. Apart from that, they tried to solve the problem of longitude and latitude. They tried to solve the problem of navigation. They wanted to solve the problem of deciding the time of the tides. They wanted to have exact understanding of the timing of the tides that came on the sea, so that would help them in controlling the sea. Many scientists like Newton, Boyle, Halley, John Wallis, Euler, Bernoulli, Laplace, etc., they made contribution to this field, to the problem of navigation, to the problem of finding longitude and latitude, to determine the time of the tide. Now, another fine example of correlation between scientific needs and interests and economic needs and social needs is that of the issue of depletion of forest resources or woods. Now, this woods were required not only in shipbuilding, but also it was required as a fuel, as housing material, and it was fast depleting. The forest reserve was fast declining because of its extensive use. So that triggered interest in botany, in trying to understand. The scientist wanted to develop botanical knowledge to solve the problem of timber and wood, which was essentially used in almost every industry in 17th century England. Now, Sir Walter Raleigh, he listed 6 major qualities of good ship. What are these qualities? Strong build, speed. The ship should have strong build, it should have speed, it should have stout scantling, it must have ability to fight guns in all weather, it must have ability to lie easily in the face of a sea storm, and must have ability to stay well. It should have better balance. Many scientists turn their attention to satisfy these requirements. So they made use of their theoretical knowledge to understand and explain and solve this problem which were needed to make a good ship with all these qualities. First, they had to solve the problem in basic sciences in order to solve the practical needs. For example, to understand the ship's speed, they had to work on hydrodynamics. Hence, it was a direct correlation between science and technology, of relationship and correlation linkage between pure science and technology, application of that, practicality of the basic science, and which establishes a strong link between a given technical task and purely scientific investigation. As I told you earlier, that they wanted to be the British, they wanted to be the master of the sea. They wanted to be superior to all the others in Europe in terms of their strength of naval forces, and hence that was a economic need, that was a political need, that was a military need, and the scientists of that country in that period, they started research in order to solve the problem of navigation, in order to solve the problem of longitude, in order to solve the problem of latitude, in order to solve the problem of time of the tide. They wanted to solve the problem of depletion of forest resources, depletion of timber and wood. Hence, botanical knowledge developed because of their interest to solve navigational problems. They wanted to be the superior naval forces. Through that, their astronomy developed manifold, their mathematics developed manifold, their mechanics developed manifold. They also tried to solve the problem of inland transport. They wanted to have faster inland transport. Not only they were looking to improve their sea transport means, but also they were trying to improve their inland transport, and that led to more scientific investigation. And because of this, capitalism directly or indirectly developed. Capitalism as a economic system developed because of this linkage between social needs and scientific and technological advancement, that led to a newer kind of economic system which we now know as the capitalism. Now, if you look at this table, this is a table which has been shown by Robert Merton to show the extent of socio-economic influences upon the selection of scientific problems by members of the Royal Society of London. The period mentioned here is 1661-62 and 1686-87. Why he has chosen these two particular years? Data of 1661 and 62 and 1666 to 87 period is because of data is easily available for him. Hence, he made use of this data, and this data reveals that if you look at the number of research activities that were undertaken by the members of the Royal Society of London, which is the scientific society of England, if you look at the total number, 333, that is 41.3%, research was done in pure science, whereas science related to socio-economic needs such as marine transport, mining, military technology, textile industry, general technology and husbandry, research on those aspects, on such social needs, it accounted for 58.7%. In terms of number, it is 473. So, this is an indicator that in the 17th century England, it is the social needs which predominated, and because of social needs, scientific research was directly or indirectly guided by that. It appears that half of the investigations conducted in those 4 years, I am referring to the table now, can be classifiable as pure science, less than half. Rest of the research were influenced by practical requirements. Problem of marine transport, it attracted the most attention, as we have just discussed. Problems of military nature left its impress upon the scientific development. They wanted to be a militarily strong force. So, a lot of research went into that. Mining developed markedly during that period because the factories were coming up, and the factories required huge amount of coal. So, factories also required minerals, ores, iron ores. So they had to develop methods of extracting iron from the iron ores. So research in the field of mineralogy, metallurgy, it was all initiated with the aim of discovering new utilizable ores and new methods of extracting metals from the ores. Finally, based on this discussion, we can always assert that the range of problems investigated by 17th century English scientists was quite influenced by socio-economic structure of the period. Right. Now, if we just go back to the first slide where we propose 3 problems, we formulated 3 problems. Now, if you again look at these problems, we will know that the belief that socio-economic factors accounted for scientific activity in 17th century England, it holds true based on all these evidences furnished by Robert Merton. Now we stop here. We will take up a new topic in the next class.